Welcome to Kindergarten Video on Demand. This video is an overview of Unit 5B, Understanding and Using Addition and Subtraction in My Life. The purpose of this video is to provide an overview of the standards, intended pacing, and sample instructional strategies for Unit 5B. In this portion of the video, we will review the AKS and Indicators of Achievement, or IOAs, for Unit 5B. The AKS is the overarching academic knowledge and skills that students are expected to master. The IOAs are the learning objectives that allow students to demonstrate mastery of the AKS. The AKS and IOAs may not be taught in their entirety the first time they appear on the instructional calendar. Some AKS and IOAs will appear multiple times throughout the year. In Chapter 2 of this video, we will look to see how the AKS and IOAs in this unit are paced in detail. This unit has 4 AKS. Under the AKS, you will find the Indicators of Achievement. You will also see that we have provided you with the state coding at the end of the IOAs so that if you are looking up resources on the Georgia Department of Education website, you are able to find the state IOA that is related to the GCPS IOA. The majority of Unit 5B is work with AKS 5, specifically IOA 5.B and 5.C. AKS 5 is our AKS which addresses students explaining the concepts of addition, subtraction, and equality to solve real-life problems within 10. IOA 5.B and 5.C introduces join result unknown and separate result unknown problem types. Unit 5A focused on the relationship between a whole number and its parts with IOA 5.A. In Unit 5B, we will build on this part-whole relationship as students are introduced to what it means to add and subtract as they solve joining and separating problems with the result unknown. IOAs 5.B and 5.C are clustered together as students represent addition and subtraction and use a variety of strategies to solve addition and subtraction of whole numbers within 10. Representations may include objects, fingers, mental images, drawings, expressions, or equations, and strategies include counting all, counting on, counting backwards, and making 10. Relevant problems include word problems that are meaningful to a student's real environment. It is important for the problems presented to be relevant and interesting for the learners to pique their natural intellectual curiosity. Van de Waal discusses the difference between story problems and contextual problems. He states, in story problems, children tend to focus on getting the answer. Context problems, by contrast, are connected as closely as possible to children's lives rather than to school mathematics. They are designed to anticipate and to develop children's mathematical modeling of the real world. Contextual problems might derive from recent experiences in the classroom, a field trip, a discussion in art, science, or social studies, or from children's literature. Students have been exposed to part whole, whole unknown, and part whole, both parts unknown with IOA 5.A. IOAs 5.B and 5.C introduce students to join result unknown and separate result unknown. Change unknown and start unknown problems are not an expectation for kindergarten. Students will be introduced to these problem types in first grade. Exposure to equations is expected, but mastery of equations is not required. Please note that it is not until first grade when understand the meaning of the equal sign is an expectation. IOA 5.D is fluency with adding and subtracting within 5. While this IOA begins in Unit 5B with the introduction of what it means to add and subtract, it will continue to be addressed in activating strategies and will be a focus of Unit 7. AKS 7 consists of physical and measurable attributes of objects and analyzing graphical displays. During Unit 5B, we will revisit Indicator 7.C. The goal is to use mathematics to make sense of the world around them by asking questions that they care about and by collecting, gathering, and interpreting data to answer those questions. Students display their data using objects and pictures. Students should be able to use friendly language to explain their data and answer the overall question. AKS 2 is an ongoing AKS which appears in all units. AKS 2 consists of students rote counting forward to 100 by ones. Starting at 10, students will rote count forward by tens to 100. This standard requires students to rote count backwards from 20. Students will also count forward within 100 and backward within 20 from a given number. This is an ongoing AKS which appears in counting routines during the activating strategy. At this point in the year, all learning targets for AKS 2 have been introduced and students are working towards mastery of counting forward and backwards. AKS 6 has been an ongoing AKS throughout the year. Students will continue to work with AKS 6 in Unit 5B. AKS 6 states that students will explain, extend, and create repeating patterns with a repetition not exceeding 4. Describe patterns involving the passage of time. The study of patterns provides opportunities for students to make connections. These connections help to build a foundational understanding of algebra as it relates to addition and subtraction strategies, the count sequence, and geometric understandings. IOA 6.A states students will describe a repeating pattern with no more than 4 repetitions of the core, which is made of shapes or numbers. This can also be extended to a repeating pattern of objects. Once students have identified the repeating pattern, they extend the pattern. Students also create patterns of their own. It is important to know when showing students a pattern to describe and or extend, the entire core should be created in the repetitions. For example, if the pattern is triangle, square, square, that entire core must be shown at least twice. Our work in Unit 5B will focus on representational repeating patterns with numbers in which students describe and extend the pattern. In Unit 6, students will begin creating patterns. With IOA 6.B, students should be able to describe patterns involving passage of time, using words and phrases related to actual events. Pacing guide is an example intended to model how instruction of the AKS and IOAs in each unit may be facilitated, but teachers should design pacing to be responsive to the learning needs of their students. Let's take a look at our pacing guide for Unit 5B. In the box, which names the unit, you will see the suggested pacing. For Unit 5B, we suggest about 6 weeks. The big ideas, numerical reasoning, and patterning and algebraic thinking for the unit are included as well, as any links we feel should be beneficial for the entire unit. Next, you will see a list of the AKS and IOAs, which have been strategically clustered together. This is followed by our suggested pacing. Specifically, the left column provides the learning progressions for the AKS and IOAs, whether this be the concrete, representational, or abstract progression, or the progression between specific learning targets within the IOAs. Suggested manipulatives are also included in this column. The right column provides resources to guide instruction. Unit 5B begins with IOAs 6.A and 6.B. In this lesson, the activating strategy will include the passage of time. The lesson will focus on representational repeating number patterns. Work will continue with these IOAs in the activating strategies. Specific activating strategy slides have been provided to support you with this work, as well as continued practice counting with IOAs 2.A and 2.B. The unit will then shift focus to IOAs 5.B, 5.C, and 5.D as students are introduced to addition and subtraction. Students will begin learning what it means to add, specifically with joining problems with the result unknown. The pacing guides suggest about 8 days, with 5 of those being at the concrete level. The pacing then shifts to subtraction with the same pacing, about 5 days at the concrete level, followed by about 3 days at the representational level. Because addition and subtraction are new concepts for our kindergartners, they are taught separately. This is intentional so that we can emphasize what is happening in the problems, helping students build conceptual understanding of what it means to add and subtract. After students have an understanding of what it means, the pacing will then shift to a mix of join result unknown and separate result unknown problems. This is when students will decide which operation to use. This is paced for a total of about 7 days, starting with 4 at the concrete level and 3 at the representational level. It is important to note we do not teach students keywords for adding and subtracting. Teaching keywords leads to misconceptions, resulting in students grabbing numbers and performing an operation based on the keyword alone and disregarding the context of the problem. The last day of Unit 5B is paced to revisit IOA 7.C, in which students will experience the statistical reasoning framework as they collect, analyze, and interpret data to answer a question. This portion of the video will highlight specific instructional strategies that will be utilized in this unit. Please refer to the Analyzing the Standards, or ATS, for guidance on additional instructional strategies for each IOA. Now, let's take a look at possible instructional strategies in action. IOA 6.A states that students will create, extend, and describe repeating patterns with numbers and shapes, and explain the rationale of the pattern. So far, students have had work with repeating patterns involving movements, 2D shapes, 3D shapes, and coins at the concrete level, as well as movements, 2D shapes, 3D shapes, coins, and objects at the representational level. So now we are wanting students to have some work with repeating number patterns. So for this problem, we want students to describe and extend the following pattern. So what we want students to notice first is that there is a core, and that core repeats. So as I'm looking at this number pattern, I see 3, 2, 1, 3, 2, 1, and then I have blank, blank, blank. So in order to extend it, I need to be able to describe this pattern first and know what the pattern is that's repeating. So I'm noticing I see a 3 in 2 places. I also see a 2 in 2 places, and I see a 1 in 2 places. So I'm noticing that I see 3, 2, 1, and then it repeats 3, 2, 1. So I'm going to circle the core, 3, 2, 1, and then I see that core repeats again, 3, 2, 1. So I'm going to circle that core. Now I know that the core is what's repeating, 3, 2, 1, 3, 2, 1. In order to extend the pattern, I'm going to repeat the whole core again, 3, 2, 1. So as students are working with repeating patterns in Unit 5B, we want to focus on number patterns and how they can also repeat in order to find the core first and then have that whole core repeat every time. IOA 5.B states that students will represent addition and subtraction within 10 from a given authentic situation using a variety of representations and strategies. And IOA 5.C states that students will use a variety of strategies to solve varying types of addition and subtraction problems within 10. We have these two IOAs clustered together as we want students to be given problems in authentic situations, but also have the opportunity to use and learn a variety of strategies as they're solving those situations. Now, at the beginning of our pacing, I showed you that we will begin with addition, and addition and subtraction will be taught separately at first so that students can understand what these two operations mean. So we will begin at the concrete level. So let's look at this situation. 4 birds were in a tree. Then 2 more birds flew to the tree. How many birds are in the tree now? So with students, I want them to create a math movie in their head, and I want them to visualize what's happening. So I'm going to model that as the teacher and tell students that I'm going to imagine that I see 2 groups of birds. I see one group of birds that's already in the tree, and then I see another group of birds that flies and lands on the tree. And so I want to know how many birds there are if I combine these 2 groups of birds. So the question is asking me to find out how many birds are on the tree once the birds fly over to the tree. So I'm going to be joining or adding these 2 groups together. And so for this situation, I want to show students that I can use a part-whole organizer, which is going to help me organize my thinking. And once I've organized my thinking to create my number sentence, then I can use a strategy to help me solve. So when I'm using the part-whole organizer, I want to label my parts. I know that I have one part of the birds that are already on the tree, and I have one part of the birds that are flying to the tree. And what I'm trying to find out is how many there are all in the tree, how many birds all together. So I know that one of my parts is the birds that were already in the tree. So I'm going to label this part birds on tree. And then I know that my other part are the birds that fly to the tree. And what I'm trying to find out, my unknown, is my whole, and that's all of the birds when I combine or join both of these parts. So when I look at the problem, I know that the problem says that there were 4 birds on the tree. So I'm going to represent my 4 birds on the tree with these green snap cubes. So I have 4 birds on the tree. I also know that the problem tells me how many birds fly to the tree. And I can represent that by placing 2 purple snap cubes of this part of my organizer to show the 2 birds that fly to the tree. But the problem does not tell me how many birds are on the tree after the birds fly onto it. And that's what I need to find out. So to answer that question, I can join or add the 2 parts together. So now I can represent my problem once I add them together. So I know that I'm going to be putting together the 4 birds on the tree, and I'm going to join it with the 2 birds that fly to the tree, and that's going to tell me how many are all together. And so I want to show students that I'm going to join all my birds together, and then I can count by touching and counting my snap cubes. 1, 2, 3, 4, 5, 6. Eventually, we hope that students will see that I already had 4 birds, and then they may count on. So I have 4, 5, 6, and that will be another strategy that students will use counting on once I know how many birds I had on the tree, and then I'm adding the ones that fly to the tree. So then students can write the equation 4 plus 2 equals 6. It is still fine that students use the sentence stem to say that 4 and 2 is the same as 6. Remember that equations do not have to be mastered in kindergarten. We do want them to be exposed to it, and we want them to learn what that means, but it does not have to be mastered. So if we are still using the number sentence here, that is also okay. After students have had the opportunity to work at the concrete level and learn strategies for adding and then learning strategies for subtracting, we will move into representational. Again, we will teach these strategies separate so that students can understand what it means to add and subtract or to join and separate. So we're going to look at a representational strategy of using a number line to subtract. So because I am telling students that we're going to subtract, the purpose of this mini lesson or my modeling of this to students is to show them the strategy and how to use a number line. Later on in the unit, when we mix adding and subtracting together, that's when I'm going to want students to think through what's happening. I'm still going to model that for students, how I would set up the problem and how I'm going to know it's adding and subtracting. But they will know up front that I'm going to teach them a strategy for subtracting. So let's look at this situation. It says Aiden has 8 chocolate chip cookies. He eats 3 cookies for a snack. How many cookies does Aiden have now? Again, just like I did at the concrete level for adding and subtracting, I want to use a part whole organizer to set up my problem so I can see whether or not I'm adding or subtracting. This is really important for students to understand that when I have 2 parts and I'm joining them together to find the whole, I'm adding. Or when I have the whole and one part and I'm missing a part, then I'm going to separate a part from the whole to find the other part, and that means that I'm subtracting. Using the part whole organizer is not a strategy for solving, it's just a way to set up my equation. So when I look at this situation, I see that Aiden has some cookies and then he eats some, and then I want to know how many he has now, or how many are left on the plate, or how many cookies he did not eat. So I know that my whole is going to be the number of cookies that he starts with, or how many are on his plate. So I'm going to write cookies on plate, and it says that he had 8 cookies. And then one of my parts will be the cookies that he eats. So these are the cookies that he has already eaten. And in this situation, it states that he has eaten 3 cookies. And what I'm wanting to determine, or my unknown, is going to be the cookies that he did not eat. Or the cookies that are left on his plate. And so that's my unknown. And because I have my whole and one part, I'm going to separate this part from the whole to find my other part. So I know that I am subtracting. I'm going to use a number line to subtract. And when I'm using a number line, because I am subtracting, I'm going to start with my whole, which is 8. And I'm going to count backwards the number of cookies that he ate, which is 3. So I'm going to count back 1 cookie he ate, 2 cookies he ate, 3 cookies he ate. And I land on the number 5. And that's going to tell me how many cookies he did not eat, or how many cookies are left on the plate. And now I can write my subtraction sentence, or my number sentence. And so I know that 8 minus 3 is the same as 5. I can also write this as an equation. 8 minus 3 equals 5. After students are taught at the concrete and representational level for teaching adding and subtracting separately, we then want to provide students the opportunity to have them mixed together, or to not be told that you're going to solve an addition problem or a subtraction problem, but that they start to think about what's happening in the situation, creating that math movie in their head, to then be able to figure out or determine what the problem is asking them, or what the problem type is. Am I joining two parts together to solve the unknown whole, or am I separating a part from the whole to find the other part? So one way that you can do this with students is to show them numberless word problems. This helps students not become number grabbers, where I'm just finding the numbers in the problem and either putting them together or taking them apart. This way, I really have to think about what's happening in the situation without any numbers. So I can't do an operation yet, but I need to think about what's happening. So here's an example of a numberless word problem where I just have the numbers blocked out. If you had this written on a chart paper, you could put a sticky note over the numbers, so that after you have set up your equation or filled out your part whole organizer, you can uncover the numbers by taking the sticky note away. So it says Alex has blank stickers. Alex gives blank stickers to her friend Lori. How many stickers does Alex have now? So again, I want to create this math movie in my head for students where I'm thinking about what's happening in this situation. I know that Alex has some stickers. I don't know how many she has, but I can actually see in my mind her taking some of her stickers and giving them to her friend. And now it's wanting to know how many she has now. So if I think about that using a part whole organizer, I'm just going to label these parts because I don't have the numbers yet. But because she's giving some away to her friend, right? And I know how many she's starting with, which is my whole. I know that I'm going to be separating the part from the whole. So I know that she begins with some amount of stickers. So these are Alex's stickers in the whole. And I know that I'm going to be told in a minute, once I uncover those numbers, one of the parts is how many she gives to her friend. So these are the stickers given to Lori. And then what the question is asking me is, how many stickers will Alex have now? So I'm going to put leftover stickers. This is what Alex is going to have left. And I may want to add her name here. Alex's leftover stickers. Okay, so now that I've set it up, I know that I'm going to be subtracting. You may even want to, as students, go ahead and write this out as an equation without my numbers. So I don't know this number, right? But I know those are Alex's stickers. And I know that she's giving away some stickers, so I'm going to subtract those. And the person that she's giving them to is Lori, and that's how many stickers Lori is going to receive. And then what is my other part, or what's left over, is how many stickers Alex will have now. Okay, that's how many she's going to have now. So I've even taken my part whole organizer and turned it into equation. So now when I uncover my Post-it notes, or my show my numbers in this problem, I can just plug my numbers in. So let's go ahead and look at those numbers. So let's uncover. So now I see that it says Alex has 9 stickers. Alex gives 4 stickers to her friend Lori. How many stickers does Alex have now? So I can plug my numbers in. I've already set up my equation. I used my part whole organizer. I have set up my equation to know that I'm subtracting. Now I just need a strategy for how I'm going to solve this. So one way that I could solve it is to use some sort of manipulative. So I could use snap cubes or counters if I'm at the concrete level. again, we want to start at concrete and transition to representational when students are ready. So because I'm going to represent my whole, I'm going to put my 9 stickers here. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my 9 stickers. Okay, and I'm going to, let's plug in those numbers. So I have 9 stickers, and she's going to give 4 of those stickers to Lori. So I'm going to take 4 of these stickers, 1, 2, 3, 4, and these are now going to be for Lori. So I've taken those stickers away and given them to Lori. And then these are the stickers that Alex now has. So I can go ahead and count those. 1, 2, 3, 4, 5. So now Alex has 5 stickers. So 9 minus 4 is the same as 5. Once students progress from using concrete manipulatives into representational, I may then draw a picture or use a number line. So for today, I'm going to use a picture. So I have already taught my students that math class is not the same as art. I'm not actually going to draw stickers. I'm going to use a very simple shape, such as a circle, that I can draw very quickly to be efficient. And so I'm going to represent my 9 stickers that Alex has by drawing 9 circles. And then I'm going to cross out the stickers that she gives to Lori. So she gives 1, 2, 3, 4 stickers to Lori. Okay, I can box those up and send them to Lori. So Alex no longer has those stickers anymore. And these are the stickers that Alex still has. These still belong to Alex. And then I can go ahead and count those 1, 2, 3, 4, 5. And that's how many stickers Alex still has. In mathematics, the emphasis is on the reasoning and thinking about the quantities within mathematical contexts. Specific mathematics strategies for teaching and learning are not mandated by the Georgia Department of Education or assessed on state or federally mandated tests. Students may solve problems in different ways and have the flexibility to choose a mathematical strategy that allows them to make sense of and strategically solve problems using efficient methods that are most comfortable for and make sense to them. It is critical that teachers and parents remain partners to help each child grow to become a mathematically literate citizen. These standards preserve and affirm local control and flexibility. From the Georgia DOE's Comprehensive Grade Level Overview.